What's up? Welcome back. We're here for computer science. What I'm going to do today is just jump into Canvas, see if there's any announcements or anything. Otherwise, I'm going to jump into my textbook, begin reading the textbook for the first time, see what that's all about, and then I'll be back to recall what I read. So I'll be back in a bit. All right, guys. My mind is being blown. Yeah, we got a lot to do for this class. I got 2 chapters. The first 2 chapters are due Sunday, so I have 5 days. Consider today, I guess, 6 days. Yeah. There's a lot. We just start. We're in this chapter 2, is the beginning of the book, really, and we're starting in chapter 2, section 1. This is about computers and programs, like a general overview. So we started with switches. Turns out computers are really just a bunch of switches. Switches were originally created in like the 1800s for like lights and simple machines. Basically, you switch like a light switch, turns it on, turns it off. That's what a switch does. And essentially, when you combine a bunch of these switches, you can do calculations with them. Okay? So the original computers were just rooms full of switches. And even back then in the 1930s and 40s, it's been a long time, almost 100 years. Even back, all the way back then, these computers could do thousands of calculations per second. Okay, so, well, first, okay, before we get into, yeah. So there are certain types of switches that can be electronically turned on and off, not just like a light switch flipped with your hands. These are switches that can be turned off electronically on and off, with a positive voltage turning a positive voltage letting electricity flow, and a zero voltage blocking electricity from flowing. So the positive voltage, that is a 1. We can represent it with a 1, and we can represent the blocked zero voltage, no electricity flow as a 0. These are bits, and this is the basis of like information for computers. Pretty interesting stuff. So that's how you got to the combinations of these electronically controlled switches. When you combine a bunch of electronically controlled switches, it becomes a circuit, and a circuit is a bunch of switches that it's just it's a collection of switches. Okay, so then we got into processors and memory. So processors are circuits or conglomerations, aggregations of circuits. So they're made of circuits, and they perform specific operations or calculations, also known as instructions. Okay, it's a list of instructions. That's what a processor does, is it can execute a list of instructions. Okay. It needs, okay, so memory. Memory is also made of circuits, stored in zeros and ones, open gates and closed gates. And processors work with memory. The processor takes information from memory, data from memory, and works on that type of data. I think it also, a processor also stores how to do its operations or execute its instructions within memory, but not exactly. It's more of the way it's the shape of and the layout of the switches in the circuit is how the memory is stored for the operations. It's still a little vague, but I think my understanding of computers is rapidly evolving. What are we forgetting? Good. Okay. This is going to be one of the densest courses I've ever taken, it looks like. It may actually take way more than 2 hours per hour, credit hour, to actually master all this stuff, but because we probably did maybe half of the first section. There's 10 sections per chapter. We have 20 sections to complete by Sunday. What? Brother, what? It's going to take about an hour, 20 hours. What? 20 hours? Bro, that's like 3 hours a day. Holy shit. We might have to just go faster. We might have to be able to, like, take all these notes and recall this stuff. I don't know. I really want to get every ounce of this, though. This is such good information. I realized computer science and artificial intelligence is like the highest leverage stuff ever, because these are the most powerful tools we've ever created as humans, and we can learn how they work and how to use them and how to utilize their potential. So, that's it for now. I've got work to do, video editing to do, business responses, emails, deal making. I got other stuff to do right now. So I'll be back to this later today. This is not my only time I'll be doing today. So that's it for right now, though. Talk to you in a bit. All right, I'm back for some more computer science textbook. We were reading about switches and processors and memory earlier, so we're going to continue reading, and yeah, I'll be back to recall in a bit. All right, guys. I'm a little bit less worried about how much work there is now. I finished up that 2.1, which is the first section of chapter 2, which is just an overview of computers and programming. And I see that, like, as long as we go along, we have these participation activities and like questions, and apparently I already have done 20% of the total participation in chapter 1, so, or chapter 2, that is. That's the first chapter. So probably won't be too bad. What else did we learn about right here? So we finished memory last time, processor memory. What would we have done then? I know we talked about programming languages, but we talked about something before that. Processor execution instructions. Programs. We talked about programs, instructions. All right, we'll just start talking about anything we can. A program, also known as an app or application, is essentially a sequential list of instructions, right? We learned about the form of instructions. Basically, an instruction can, the two types of instruction we learned about were basically you state the location of a piece of data, then you say what operation you're going to do, such as multiply, divide, whatever, subtract, add, and the number you're going to divide by or multiply by or whatever you're going to do to it, and then you're going to state the location to store that information. And that will all be in binary, and that is machine. Yeah, we'll just say that for now. So we talked about programming languages. So first of all, that instruction can be written in binary, and when it's written in binary, that's known as a machine level instruction, machine instruction. And a program at the machine level, meaning it's written in binary, that's known as an executable or a machine executable. Okay. So that was how people originally programmed in like the 1940s. In the 1950s, they created, I think it was IBM, created something known as an assembler, which basically allowed people to write programs a little bit more in the language of humans and how humans think, compared to binary. And so an assembler took this higher level, more abstracted instruction to help the human think through it more on the human language level. An assembler converts that into machine executable, basically binary. So that's what an assembler does. An assembly level language, that's what is written to give to an assembler. And then in the 1960s, and now that, first of all, before I go on, assembly level language, I believe, is now known as low level programming language. In the 1960s and 70s, high level languages were created initially to be able to write in like formulas and algorithms. So some of the original high level languages were Fortran and Algol, something along these lines. It was like because they were for formulas and algorithms. Then instead of an assembler to turn high level language into machine executable, it's a compiler that does the same thing. It takes a high level language and converts it into binary. And again, binary is essentially zeros and ones, but that's symbolic representation of switches being on and off. So everything really at the end of the day is just switches. I think that's basically everything. The other instruction we learned about is jump, which will just take a jump to a different instruction number in the program. The program starts at location 0. All right. Machine instructions. Executable program. So I was saying machine executable, I meant executable program or executable. Assembly level language instructions. Assembly language instructions. Fortran, Algol, yeah, compilers. Cool. All right. Ton of information there. But yeah, I think that's basically it for now. We'll continue moving forward, possibly later today. Depends on how much time we have. But for now, if I don't see you later today, that's it for today. Talk to you later. See ya. But I might be back.